Right, I'm using a free online graphing calculator. Here's the address here. It's desmos.com, desmos.com. Want to use this to show you how we're going to come up with the equation for week 5, skills number 1. And we start with a graph of y equals the square root of x. And over here, this tells you I'm graphing a function of x. Um, and you'll see that the graph only shows this positive portion right here, like the square root of 4 is 2. The square root of 1 is 1. You see this is marked off in half, 1, 1.5, 2. And because when you write a problem, you indicate if you want both the positive roots and the negative roots. Now, if I were to introduce a square root into a problem, as we've done in many that we've solved in previous weeks, we have to throw in the plus or minus. But this problem simply means for f of x or y equals square root of x, just the positive square root. So it only graphed this side of the equation. You think, or this half of the parabola almost is what you would be thinking, because x equals y squared would be the whole parabola along here. And so now what we're going to do, we want to reflect about the y-axis. So I'm going to keep that particular red graph there as it is. And I'm just going to go over here and grab from my miscellaneous functions my square root. And I want to reflect about the x-axis. So I might think I need to just change that to negative x. Well, did that reflect about the x-axis? No, because I would have to fold on the y-axis for this to be a reflect. So I've put my negative in the wrong place. I'm going to go back over here, and I'm moving my negative outside of the radical, and you can see that I'm now reflected about the x-axis, because if I fold on this axis right here, it would be like symmetry. It's a reflection over that line. All right, I want to shift right 3 units. So let me try adding 3. Well, that shifted it to the left 3 units. With shifting left and right, you do the opposite of what you think. When I subtract 3, it shifted over here to the right 3. Now, the question you might think of is, and this was right where it is here, but what if we had put it outside of the square root? You see, outside of the square root here, the change of 3 impacted not the x value, but the y value, because it moved down. So it was correct to have put it in here for the minus 3. So now, when we need to go down 2 units, now we want to move down this way. So with up and down, you add and subtract as you would think you would, not like the moving across. So we're going to subtract 2, because I want you to see that if I added 2, it moved up. So we're going to subtract 2, but you have to be careful to make sure that your subtraction is outside of this radical right here, that this radical ends there. And here is our final answer here. So the equation that you would answer on this problem would be y equals negative square root of x minus 3. Clearly show that your square root ends, minus 2. You could put negative 2 minus, get my square root, x minus 3 if you wanted to make it very clear. And you can see my purple line graphed right on top of my green, that the 2 is not under the radical, because if you were to put the 2 under the radical, or even minus 2 right there, you'll see that that moved it over 2 from where it was, which is not what we wanted. So hopefully seeing what's going on in the graphs helps you understand when you add to where and when you subtract.